So we switch the x and the y. We squared both sides, so we get x squared equals y minus 4, and we're going to add 4 to both sides. We're going to get x squared plus 4 equals y. Now you have to be careful. This one's a square root, so this one has a domain restriction. And this one's quadratic, so it does not. For them to be inverses, we're going to have to restrict the domain. So we know the range here is y is greater than or equal to 0. So the domain here has to be greater than or equal to 0 because we just switched x and y. So we know this one's going to go up 4. And then we're going to dot in our y equals x line. If I were to fold it, they would fall on top of each other. So we know they're inverses. If I did not restrict the domain here and continued it up, they would no longer be inverses because there would be part of this function that would not fall on part of that function. For 3, we got f of x equals x cubed minus 2. So again, I like to find my y first and write that down. So we know y equals x cubed minus 2. This is my original. And I can graph that, so I know I'm going to go down 2. And I'm doing my cubic function. I'm going to switch x and y. I'm going to get x equals y cubed minus 2. That's my switch. And I'm going to solve for y. So I'm going to add 2. X plus 2 equals y cubed, and then cube root both sides. So we're going to get y equals the cube root of x plus 2. We can rewrite that as f negative 1x, or the inverse of the function is the cube root of x plus 2. And so that tells me I'm going to have a cube root. I'm going to go right to. All right, to left 2. I'm sorry, people. So that's left 2 because the inside's positive. I kind of caught myself mentally because I knew it had to reflect over the line y equals x. When I start graphing, I was like, that's not reflecting. What did I do wrong? There's my y equals x line. If I were to fold it, it would reflect. So we know for sure that they are indeed inverses of each other. If two equations are inverses, then we know they have to reflect over the line y equals x. If we do our composite functions, we would know that f of g of x will equal g of f of x, which would all equal x. So if we do our composite functions, they should all simplify to x, which is what they reflect over when we do it. So if I have f of x and g of x to determine